All right, so thank you all for joining us tonight for the Moongazing program. I have with us Mr. Brian Cummins, who has very graciously agreed to do our program.
Well, good evening, everybody. My name is Brian Cummins. I am very happy to be with you tonight. Ginger, thanks very much for the invitation. This is a cool week for the moon. We're going to talk about that in a little bit. But and this is an iconic picture for those of you who have seen it before. This is a picture of Buzz Aldrin that was taken on the surface of the moon all those many years ago. It's one of my favorite pictures of all time. Super cool. And one of the neat things about that is you can see the footprints on the surface of the moon. And as there's no, or very little anyway, atmosphere on the moon, those footprints will be there for a very, very long time. There really is no erosion on the moon. My name is Brian Cummins. As I said, I'm a member of the Northern Virginia Astronomy Club. That's www.novac.com. I live here in Chantilly, Virginia. And I'm also a volunteer with NASA on a program run by the Jet Propulsion Laboratory called the Solar System Ambassadors. And so we do outreach and events like this, talking about space-related type things. And then also I have a new Instagram account because my main passion in astronomy is astrophotography. And I've done a number of these presentations before, and people say, "Hey, where do I go see more of your stuff?" And I've just never had something to point them to. So I created that Instagram account in case you want to see more photos that I've taken after this. More than happy to do it. Just to give you a little background about me as we go to the next slide, if it would advance. There. Okay, so I am not professional astronomer. I don't work in the sciences at all. As a matter of fact, I'm a technical guy. I work in the IT field, but I've been a space enthusiast my whole life. And about 10 years ago, I decided to go and get my first telescope. I just kind of got the bug, and I actually went to a Northern Virginia Astronomy Club event, a public night, where people can come out and look through our telescopes. And I took a look at some of those and saw some planets, and I was immediately hooked. I think I had my telescope on order within a few days, and that just brought me down the rabbit hole. And so I bought more telescopes, and eventually I decided to start taking pictures. And that has really become my primary passion in astronomy, is astrophotography. So that's a picture of me out with a setup that I use often. That's a refractor telescope, similar to design to what Galileo used when he first looked through his telescope. And it's sitting on what's called a German equatorial mount. That mount is really good for astrophotography because it allows tracking over long periods of time, over through the night, without rotating the frame. And you can see there's a whole bunch of wires on there that run my focuser, that run the camera, that run the mount, that all go back to a laptop that's on that table behind me. That picture is taken from Sky Meadows State Park, which is a dark sky site here in Virginia, so up the road in Delaplane. Where they have events monthly called Astronomy for Everyone, where you can come out and do what I'm talking about. Have a public night. There's usually a presentation. You can come out and look through telescopes and see some of this stuff live, which is cool. And I mentioned I'm a member of the Astronomy Club and also of the Solar System Ambassadors. So that's a little bit of my background. So I mentioned I'm a big fan of astrophotography. These are some samples of my work. I thought I'd shared like a couple different nebulae up top here. This is the Iris Nebula at the top left. That's one I took just within the last week or so. I finished that one. Down at the bottom is the Andromeda Galaxy. That's our closest neighbor from a galactic perspective. It's about 2.5 million light years from Earth. This is another one here called the Crescent Nebula, which is an emission nebula. And then hopefully we recognize Saturn and Jupiter. I'm less of a planetary photographer than I am more of the deep space type things like we see here with the nebulae and the galaxy, but it's all fun. It's all fun to do. Incidentally, I've got a number of pictures throughout the presentation tonight of the moon, which are all my photos as well. So I'm very happy to share them with you tonight. All right, so let's talk about our closest neighbor, which is the moon. You know, if you're like me, I've got, you know, I think we all kind of have a bit of a fascination with the moon. I mean, you know, how often you walk out at night and go, oh wow, look at the moonrise, like that's awesome, or wow, the crescent moon, that's really cool looking, right? I mean, it's one of the first things I do when I go outside. Is first thing I do is typically is look up and see if it's clear, because I'm very interested in that. But I also look for the moon to see, you know, what it looks like tonight. And it's funny, before I got into astronomy, I wasn't really super aware of what phase of the moon we were in, of, you know, where it was in its orbit around Earth. But as I got more into astronomy and realized that actually it's a lot easier to do visual astronomy when it's a new moon, because actually the moon becomes a source of light pollution, and light pollution is really bad for astronomy. It sort of washes out everything and makes it harder to see everything. So I'm keenly aware when a new moon is coming up. I typically don't schedule, you know, dates with my wife or things on new moons, just in case it happens to be clear. Because if it's clear on a new moon, I definitely want to be out observing and taking pictures. But I think we all sort of have this fascination with it, or many of us do anyway. And I was thinking about that, in, you know, how that relates to culture. Certainly, you've seen a gazillion movies about the moon. I was thinking about just songs that I know. Right. I mean, there's Pink Floyd's Dark Side of the Moon, Moon River, Bad Moon Rise, and, you know, Glenn Miller, Moonlight Serenade. There's all these songs about the moon, all these movies about the moon. There's just huge fascination with it. And it's you know, and for good reason. It's a really cool thing to look at, and it's a really interesting thing to look at, and really good through a telescope. So I don't know. I just, as I was thinking about this presentation, I thought, man, just think of all these songs. Anyway, kind of neat. And by the way, I Googled, you know, what are some great songs about the moon? Gave me a list of like 100, you know, and those are the top 100. So, you know, who knows how many there are. But anyway, thought I'd share that with you. So, just a few facts real quickly about the moon, just to give you a sense. And again, this is one of the pictures I took of the moon. Um, the average distance to the moon, and of course, the orbit around its orbit around Earth is not, you know, is not perfectly circular. It's a little bit elliptical, but on average, it's about 239,000 miles from Earth. So it's a pretty good distance. And, you know, you think back to the Apollo missions. For those of you who remember, when they flew from Earth to the moon, and it's not exact, and it was a little quicker coming back than going typically, but um, it took about 3 days there and about 3 days back, each of those trips. So that gives you some idea of how far away it is. Um, you can see what's next. I put the rotational period and the orbital period, and the difference between those two is the rotational period of the Earth, excuse me, of the moon, is the time in Earth days that it takes to rotate on its axis one time. 27 days. It's actually like 27.32 days. Its orbital period is the time that it takes for the moon to orbit once around the Earth completely. It's also 27.32 days. What that means, and it's actually not unlike a lot of moons in our solar system, is that it's tidally locked to the Earth. Well, what does tidally locked to the Earth means? It means over the many millions of years, or a few billions of years, that the moon has um, orbited around Earth. It's gotten to the point that the gravity has grabbed a hold of the moon, and it rotates in such a because it orbits once on its axis the same amount of time it takes to turn all the way around the Earth. The same side of the moon is always facing Earth. So that's why when you look at pictures of the moon, aside from the different phases, they always look exactly the same. And it's because from our vantage point, we can never see the back side of the moon, at least, you know, from our vantage point, sitting here on Earth, because the same side of the moon is always facing us. And that's because it's tidally locked. Interestingly enough, one day on the moon is actually 29.5 Earth days. So, which is kind of a cool thing when you think about it, is if you were on the moon, and we're looking to have manned missions to the moon. I think Artemis is looking to have manned missions on the moon as soon as, well, maybe starting in like 2025. Um, if we have colonists, or we have a base on the moon, that's part of what Artemis is trying to get to. You would be in daylight for 2 weeks, and you would be in darkness for 2 weeks. That's how long, you know, it takes for a day on the moon. The diameter of the moon is 2,159 miles. That's about a third of the size of Earth. and its mass is 1.2% the size of Earth's, and that means the weight essentially of the moon is much smaller than that of Earth. And so that's why when you see old videos of the astronauts who were on the moon that were jumping and they were sort of doing that kangaroo bunny hopping that looked, really cool, it's because there's much less gravity on the surface of the moon than there is here on Earth. The moon is our only natural satellite. Um, it's somewhat unusual in our solar system. Um, Many of the planets in our solar system have, almost all of them, with the exception of Mercury and Venus, every planet in our solar system has moons. We're the only one to have just one. Um, I guess we do like a little quiz here. Does anyone know how many moons Mars has, for example? Feel free to jump in. Oh, I see it. Someone knows too. Outstanding. Good stuff. And we know, so yes, Mars has two moons, Phobos and Deimos. Jupiter has 79 moons, surprisingly. The four that we're most familiar with are the four that Galileo first saw when he looked through a telescope. And if you look through a telescope now, if you have a chance to look at Jupiter through a telescope, you can see those four moons shining brightly, and you can see how they change through the night. And that's Io, Europa, Ganymede, and Callisto. Saturn has 82 moons, Uranus has 27, and Neptune has 14 moons. So somewhat unusual here on Earth to just have one. But poor old Mercury and Venus are lonely, they have none. Interestingly, the chemical composition is very similar to Earth's, which is which has sort of changed how we look at how the moon was formed. There have been multiple theories over the years of just where did the moon come from? Like, how was it formed? Some had thought of, okay, well, maybe it was an asteroid that was captured in Earth's gravity and sort of became our moon. But when we flew astronauts to the moon and they came back with moon rocks, and they realized that the composition of the moon looked very similar to what we have here on Earth, they started putting together a model that looked like this was maybe like a big collision, that the moon may actually come from the Earth of when the solar system was first forming. So just to give you some idea, this is sort of an artist's rendering of what that looked like. So this is 4 billion years ago or so, as the Earth, which is the big planet in that picture on the left, as it's forming. There's a planet called, it's sort of theoretical one, but they've named it Theia, that smashed into the Earth at high rate of speed, creating this huge sort of explosion and impact. And at the time, Earth was sort of, there was a lot of sort of molten lava inside the planet, so that huge explosion sends all that debris out into space, which sort of formed a ring. And then eventually, over time, as gravity got to work, that debris coalesced and created the moon. And so that's the current thinking anyway. I saw a new model this week, or maybe I saw a story on it last week, that there may have been two collisions that created the moon. So it's interesting. It's our closest neighbor. It's one we're all very familiar with. And there seem to be good theories of how it's formed, but we don't know for sure. And I know that they will still work on that to see see if we can figure it out exactly how it was. But the latest, sort of the most current thinking is that that's probably how it happened, is with a collision with early Earth. Okay, next slide. So I thought I'd quickly talk about the lunar phases, just to give you some understanding of how the moon changes and why it changes for how we see it. And so what you have around the outside are the different phases of the moon. So it orbits around, this goes counterclockwise in this case. So it starts with a new moon where we can't see it because it's in sort of the dark side of, not dark side, how should I explain this? In the middle circle, right, where you can see it right around Earth, you can see that the moon is always half lit up by the sun. It depends on our vantage point, though. As we're looking at it, we may not be able to see the entire half that's lit up. The only time we can see the full half that's lit up is at full moon. So in this picture, essentially the sun is over to the right and it's shining on the moon. And as it moves around, you can see how that changes our perspective on the moon and why it goes from a waxing crescent to first quarter to waxing gibbous to full moon, etc. And so this is why we see the different phases of the moon. So interestingly enough, this is a very good week to talk about the moon. Ginger was way ahead of the curve on this because she looked out looking for someone to come talk about the moon. What, back in probably August, Ginger, I think we first started talking about this.
We planned way ahead in the
You
libraries.
did. So does anybody know why this is a sort of a big and interesting week for the moon? Feel free to jump in.
I know.
Go ahead.
So from what I've heard, there's supposed to be a lunar eclipse this week.
There is a lunar eclipse this week. That's exactly right. So this Thursday night, and we'll talk about it a little bit more. This Thursday night, really, it's more like early Friday morning. For those of you who are willing to stay up late and brave the cold, it looks like we're going to have a pretty good look at it. So the other thing, one of the other things that the moon is responsible for is for creating the tides on Earth. And so any of you who've gone to a beach, have probably seen low tide versus high tide, where at high tide the water comes way in, and then a few hours later it starts moving out, and the water seems to just go out to sea. That's low tide, high tide, and that's caused essentially by the gravity from the moon. And so as the moon and the Earth are attracting each other essentially through gravity, which as you see in this picture, and I'm assuming you can sort of see this animation, is it causes the water to bulge on two sides. Interestingly enough, you wonder, okay, well, wait a minute. So the gravity is pulling, right, the water. Why does it bulge on the far side of Earth? And the answer is, so because gravity is weaker on the far side of Earth, that water starts moving away from the Earth due to the inertia of the spin of the water on Earth. And so it creates a sort of bulge on both sides. And then so what happens as the Earth is rotating, our beaches, our coastlines move through those areas of high tide and low tide, and that's what makes the water look like it kind of goes in and goes out, gets deeper. And clearly this is not to scale, because that's a very tall person who's rotating around the Earth. But that's where tides come from. So I thought I'd spend a little bit of time talking about the lunar features, and there's more than what I've listed here, but I just thought for the sake of brevity, we talk about the big important ones. So there's the highlands of the moon, which is the sort of, in this picture, the white areas, or whitish, grayish type areas. That was the original crust of the moon, and as the moon was forming and it was sort of very molten, the light materials such as aluminum and silicates sort of rose to the surface and created this sort of whitish, grayish crust. And then as the solar system continued to form, there's this time of just massive bombardment of Earth and the moon, really, but the moon has no atmosphere to protect itself, of asteroids, comets potentially, that hit the moon. And you can see, I mean, over billions of years, sort of all the scars, all these craters that you see on here were created by a collision of some sort of asteroid or potentially comet, and creates an impact, creates a crater that really sort of pockmarks the surface of the moon. And when I talked earlier before about just the footprints of the astronauts stay there essentially forever, similar to what happens with these craters, is they stay there for a long time. The darker areas are called the maria. That is the Latin term for seas, for oceans. And the reason they were named Maria is the original astronomers, or first astronomers who were looking at the moon, thought maybe this was, water was held in these as they were looking up at them. Obviously, today we know that isn't so true. But those are the Maria are the dark, mostly featureless areas on the surface of the moon. They were created when like a big asteroid impact or something impacted in a big way that sort of broke open the crust of the moon and allowed lava to come out, basalt lava rock. So this lava comes out and is this dark sort of color that sort of filled that area. So, if it's very similar, by the way, if you look at pictures of sort of the black beaches or the black volcanic formations on Hawaii, for example, very similar process that's going on there, very similar material, and so that's what those dark areas are from, and those are the Maria. Next slide. So thought I'd walk through just some of the areas, some of the things that we have named. You can see there's still volcanic activity on the moon today. So there are no active, certainly, volcanoes on the moon today. There is, however, seismic activity. So we know that because when the astronauts went to the moon, they were able to measure that, and so there is some sort of tectonic type plate shifting going on because they were able to pick that up when they were there. But no, there, as far as somewhere, there are no active volcanoes on the surface of the moon. So a bunch of different areas here, and we talked about that. They're called Maria. We sort of loosely translated them to seas, and you can see there's maybe one of the most famous is the Sea of Tranquility. For those of you who remember, that was where the original astronauts landed on the moon. There's a couple craters that I pointed out here. Tycho and Copernicus are some of the most famous. Honestly, for people who are really into the moon, who really understand sort of who really are really into it, there's a lot more features of the moon that have been mapped, named. You can certainly follow up and look at, there are lots of maps, lots of diagrams that point out exactly what all those are. But I thought I would share with you just, some of these: Sea of Tranquility, Sea of Serenity, Copernicus, Tycho, Ocean of Storms, etc. So I put these numbers on here. Would anyone hazard a guess what the significance of those red numbers are? Any guesses? Someone's got to have a guess.
I have a guess.
What is it?
That's where the rovers that have been sent to the moon are.
That's very close. So this is where the different Apollo missions, the manned Apollo missions, actually went to the moon and where they landed. So Apollo 11 was the first to land. Its touchdown in the Sea of Tranquility. And you can see 11, 12, 14, 15, 16, and 17. Notably missing here is the number 13. And I'm sure, well, maybe not everyone knows why, but Apollo 13, if you've ever watched the movie, is the one that had a mishap on the way to the moon, an explosion inside the capsule, and the team did a heck of a job just getting them back. But they got to go around the moon and come back, but they were not able to land on it. But those are the 6 sites where we landed people on the moon, and a total of 12 men have walked on the surface of the moon. And coming up in hopefully 2025, the Artemis missions that I talked about. The plan is to have the first 2 people to land are a woman astronaut and an astronaut of color. So looking forward to those missions. And those Artemis missions are also hopefully planning to get us ready and get us geared up to send manned missions to Mars at some point, which is super exciting. Okay, any questions? Okay, I'm trying to keep an eye on the chat window. So this is kind of a cool picture, and it's actually a similar picture. It's actually the same picture from the last one that I took, and I took this at the last full moon, which is just about a month ago. And it's called the mineral moon, and this is an enhanced photo where I use some tools to really bring out the saturation of the colors that you can't see with the naked eye, but it's in the data in a picture. And if I enhance, sort of like turn up the color, essentially saturate the color, make it darker, it starts coming out. And those blue areas are areas that are very rich in titanium, and the orange areas are sort of poor in titanium and iron. And it's funny because I saw someone had done this, and I wasn't really sure if it was kind of real or whatever. But I took a picture, tried it myself. I compared it to other people's data, and it's, I mean, very much the same. So it is there. It's just sort of a cool view of the moon that shows a little bit more of sort of what's in there in terms of the elements. Okay, so since we're having eclipses this week, I thought I'd walk through maybe a little bit of a quiz. So this is the first type of eclipse. This is when the Earth is between the sun and the moon. Anybody know what type of eclipse this is?
Solar eclipse.
What do you say?
A solar eclipse.
It's actually backwards. This one is a lunar eclipse, because this is when the shadow of the Earth is following the moon. This next one is what happens when the moon is between the sun and the Earth. Which one's that? Whoever answered, I want to say it again.
A solar eclipse.
It's a solar eclipse. This last one is tricky. So we got a lunar eclipse, we've got a solar eclipse. This is when the sun is between the Earth and the moon. What's that? That's called the apocalypse. Just kidding. So that would be the end of the world. It's not going to happen. We don't have to worry about that. But anyway, I saw that joke a while ago. I thought I would, I got a giggle out of it. I thought I would share that. So the one that's coming up, though, this week is a lunar eclipse. So what's that going to look like? Well, it's this Thursday night. It's a near total eclipse, and I think it's the longest near total eclipse of the century. It starts at about 2 o'clock and ends at about 4 o'clock. The really good news is, if you look down here at the right, and I've been keeping an eye on this all week, it's improving. So this is an app that I use on my phone that shows what the cloud cover looks like. It hourly, right? So this is Thursday night, 100% moon, which means it's a full moon. And this cloud cover at the time, so this is going to be from about 2 o'clock to 6 o'clock, shows 1% total cloud cover for the night. So that's potentially very good news for us. This picture of the moon here is one I took, I think it's the last lunar eclipse that I can remember anyway, that we had a good shot at. It was in January of 2018, maybe. So this was during a lunar eclipse, and it turns that sort of reddish color. And I remember freezing my tail off. It was January, and the wind was blowing. It was cold, and I was out for several hours. But it's kind of a really cool and eerie thing to see. So I encourage you, if you are able to, if you can get up, it will peak at about 4 o'clock in the morning, and that's when it will look very red. But to give you sort of a bit of a timeline on what that looks like, and I took this diagram from space.com, is at about 2 o'clock in the morning, it will enter the penumbra. Penumbra is sort of not a full shadow of the Earth. When you get into the umbra, which is really the full shadow of Earth, that starts happening about 3 o'clock in the morning. And at 4:03 in the morning, our time, this is all our time, it will be at its peak and should look pretty orange. And so hopefully, if we've got the weather for it, we'll all be able to see it. And then by 6 o'clock, the event is over. But it'll be about 50% at 3 a.m., 50% at 5 a.m. But at 4:03 in the morning, that's when it'll be at its peak, and it'll be should be something very cool to see. You know, I've seen this live multiple times. I've seen solar eclipse once. I saw the last one in 2017. You know, and I often think of what it must have been like for people who saw these events take place, particularly a solar eclipse, or either, and wonder just what is it that I'm looking at. And in fact, there were before civilizations really knew what was happening there, really understood, astronomy and had a really good understanding of what created these eclipses. There's all kinds of sort of superstitions that went along with that, or concerns that, and same with comets and other things, that it was some sort of bad omen, or there was a change in leadership coming in the country, or there's all kinds of interesting myths that sort of came out of that. But when I saw the solar eclipse in 2017, where essentially the sun disappeared, and there's just this black hole with the corona around it. Yeah, it's one of the things I was struck by, just how frightening that had to have been if you experienced an eclipse without knowing it was coming, just out of nowhere. It must have been just terrifying. But this won't be terrifying because you know what it is, and it will happen this Thursday night. Slash Friday morning. So, do you want to learn more about things in space? What can you go to do that? Well, one, library, of course, right? Ginger's Dale City Library has put this together. I have to point that out. There's all kinds of books in the library. You can look in the catalog online and just see how many books there are. There's books for adults and for children. Definitely go check out your local library. They have all kinds of resources that you can look online, of course. Um, on nasa.gov, you'll find all kinds of things. There's all kinds of sites in there for educational sites for children. So if you are interested in that, you can check those out. Sky and Telescope is another great one for astronomy, as is space.com. There's also apps that you can download for your phone. So whether you have an Apple phone or a Google phone, there are a number of apps in the app stores that you can go to, many of which are free, that you can use your camera, and you can hold your phone up and point it at the sky, and it will show you essentially what it is that you're looking at. So there are plenty of times that my parents will call and say, "Hey, what's that bright star that's up in the sky right now? It's kind of in the south." And I say, "Well, that's Jupiter." So they can call me, or they could get this app where they can kind of hold it up and it will show you on the screen, what star or what planet it is that you're actually seeing, and help you to learn the night sky, which is really cool. Another resource that I mentioned to you, I'm a member of the Northern Virginia Astronomy Club. You can come to our website. It's at novac.com. And on there, you'll see the upcoming events. Like this was taken a while ago, I guess, or no, I took this one just the other night. So we've got an event coming up November 27th. It's a public night at Great Meadow. And there's a number of these. We do at Sky Meadow State Park. We do at Crockett. Just down the road south of Manassas. So if you'd like to come out and look through a telescope, see what it actually looks like, see what the moon looks like yourself through a telescope, which is really cool. I can't tell you how many people have looked through my telescope at the moon and said, "Oh wow, this is awesome." But you can see all kinds of things, other planets, Jupiter, Saturn, Mars, Uranus, like all kinds of things. And we can show you other galaxies. We can show you nebulae. We can show you all kinds of things that are night sky. And on those clear nights, just to be out and underneath the stars is just, it's really nice. And we do those year round. Typically, we do them near to a new moon. Again, because I mentioned we have the moon is actually a source of light pollution, and so it's a little easier to see things when there's new moon. But this week should be cool. This week should be cool, and I think that's all I had. So again, my name is Brian Cummins. Clear Horizons Astronomy, or Clear Horizons Astro, is the Instagram account I created. If you want to go see some more of my work, and I'll continue to add things to there as I take new pictures. But that's my presentation. How close was I? I'm a little short. Sorry. Too short tonight.
Does anyone have a question before we wrap up, though? A second or two. That was awesome. Thank you so much for hosting tonight.
What's the temperature on the moon? So the temperature on the moon ranges from, I want to say, in the neighborhood, I'm trying to remember, I might get this backwards. In the in the light up to 400 degrees plus or minus Fahrenheit, and when it's dark and in the cold, it's minus 200 degrees Fahrenheit. I'm almost sure I've got that right. I'm close. I'm close, if not identical, but it's about that. So very hot, very cold for sure. And it's got an interesting topography. Does it have a core that we know of? Yes, we do think that it's got um, a molten iron core similar to Earth, and that's why there was the volcanic activity essentially as the crust was opened up. That's what allowed that sort of magma and that lava to come out and to create those maria. So yeah, we do think it has a molten core. Other questions? Topography. Yeah, so as you can see as you can see in some of those pictures, there's all the craters, all the pock marks, but what you really can't tell from those pictures is just how tall and how deep those craters go. And when you look at the topography of the moon, from the highest points, I want to say it's something like about 5 miles above the mean surface of the moon, and the deepest parts go about 6 miles below the mean. And that's very similar to what we have here on Earth, right? So our highest mountains are about that high, and our lowest trenches in the oceans are, about that low. What's interesting about that is, they have the moon has a similar spread, but on a much smaller ball, right? So it's it's a lot more choppy than the Earth would be essentially. Like it's got a much more, considering its size, it's got a much wider range in topography than the Earth has. Does the color of the sky ever change on the moon? I would say not particularly. It would always be black. The reason we see color in the sky is the diffraction of light in our atmosphere. There's almost no atmosphere on on the moon that would change the color of the sky. So other than it being light and dark as it has its 2-week days and 2-week nights, and no, I wouldn't anticipate that the color of the sky would change greatly on the surface. I saw another question pop up, but I can't remember what it was. Or was it chat?
What's the biggest crater on the moon?
What is the biggest crater on the moon? Candidly, I don't know the answer to that. Let's see if we can go back. And there's probably different answers to that question depending on what you look at. I mean, there's probably the deepest crater, there's probably the widest crater. I would think that, the largest sea, I would say, the largest maria on there is probably, I would guess, the Sea of Rain. I'm not expert enough on all the various craters on the moon to tell you exactly which one is the biggest or the deepest, but yeah, so that might be one you can Google. I don't know offhand. Other questions I haven't seen.
Have any yet?
Okay.
Give a couple more seconds in case someone's typing.
Of course, plenty of time.
Awesome. Thank you so much for doing this for us this evening.
It's my pleasure.
And hopefully we will find you on Instagram.
You're welcome to join me. Absolutely.
That'd be great.
And if you, the other thing in my role as a solar system ambassador, I heard there's some kids on the call. If you have interest in having someone come to your classroom and share something like this, or share things about the solar system, or about about NASA programs in general, my email is on the deck. Feel free to have your parents contact me or have your teacher contact me. I'd be happy to come in and meet you and talk to the teacher and hand out some NASA stickers and cool things like that. So if you're interested in that, certainly reach out to me by email, and I'd be happy to arrange something for you.
Awesome. Thank you so much, and thank you all for joining us tonight.
Thanks very much.